So good afternoon, everybody. Thank you for registering for the UK and Ireland's VPF Enablement Series. My name's Carl Bavington. I'm one of the Solution Architecture Managers here at Broadcom. And today we're going to be joined by Duncan Appleby, who's one of our vSAN Solution Specialists. Today we're going to be covering vSAN Snapshots. But before I hand over to Duncan, I just wanted to talk through and make you aware of the changes to the Explore season. So obviously, we've still got our Las Vegas flagship event running from the 25th to the 28th of August. Registrations for that will be open from the 29th of April. The change this year is that we're going Explore on tour. So I know a lot of people historically may have struggled to be able to get out to either Vegas or Barcelona, but this year we'll be having an event running in London. So hopefully a lot of you who's not been able to previously get out to either Vegas or Barcelona will be able to join us. Currently, we're expecting that to be mid-September. As soon as I have more details, I'll update it in the webinar. So thank you very much for joining us. As we go through the session, please feel free to utilize the Q&A. We have colleagues on the line who will be able to respond to some questions. We'll do our best to get through those. So on that note, thank you very much for joining us, Duncan. If you can just give us a quick intro and take us away.
Thank you, Carl, and welcome everyone. So Duncan Appleby, Solutions Architect here in the UK. And to get the full title of this webinar we're going through this afternoon, so it's using vSAN snapshots to expand your protection capabilities. So let's get started. First of all, a disclaimer. Everything I'm speaking about today, bar one slide that's very clear, is all current capabilities within inside the product set, and one is slightly forward-looking, but I'll be sure to call that out. So let's start from the top. 2.5 years ago, in August 2022 at VMware Explore, we announced vSAN ESA. So a new, fast and efficient, optional vSAN infrastructure architecture that was available with inside vSphere. And that change really came about from the capabilities that we had with the changes to CPUs, network cards, and particularly NVMe drives. So with that new hardware that was available on the market, so higher CPU core counts, increased clock speeds, as well as the prevalence of 25 and 100 gig networking, that really allowed us to push hardware a little bit more. And the fact we can have NVMe drives, so high capacity, real amounts of throughput available, meant by changing some of the areas of the vSAN code, meant that with vSAN ESA, we were able to really take advantage of that by creating a new fast and efficient data path. We also changed the snapshot engine, so really what we're talking about today. And we also made some changes in vSAN ESA, Express Storage Architecture, with administration as well. And so in this area, we took the opportunity whereby perhaps there were some tasks that in certain states within inside vSAN, we might expect an administrator to make some decisions. So an example might be, we had a cluster that was in an extended period of maintenance mode. Perhaps we had a failure of a couple of hosts, and we might prompt the administrator of what they wanted to do in that scenario. So what we're able to do is actually have vSAN make intelligent decisions, make changes to how it distributes data to really protect the integrity of those virtual machines. Towards the bottom of this slide, you can see there's a notion of a single tier. So within inside vSAN ESA, we changed how we were working from vSAN OSA, original storage architecture, whereby we had the concept of disk groups and cache and capacity drives. With inside vSAN ESA, those concepts of cache and capacity have gone away. We just have a single tier of fast NVMe storage, and all of those disks in all of the hosts all contribute to a single data store. But there's some things that remain the same as well. So storage policy-based management. So with inside vSAN ESA and OSA, we use storage policy-based management to assign storage resources very much in the same way as we do with compute and memory resources. So for a virtual machine, we assign perhaps a couple of vCPU, maybe 128 gig of RAM, and we also assign storage by this policy. So for example, in the middle here, we see site disaster tolerance. So if we've got a stretch cluster in place, as part of our storage policy, we'll define whether we want our virtual machine to be protected and have to be copied across two sites. We can also define failures to tolerate through erasure coding. So how many errors we want our VM to be able to survive with inside the infrastructure. That error could be a disk failure, could be a host failure. An example saying we've got a failures to tolerate of 1 with a RAID 5 configuration on screen. We can also push performance or maybe even throttle it back a bit. So by increasing the number of disk stripes. So an example here, just a single disk stripe, we can expand that out, perhaps to 2 if we want to spread our data across a greater number of disks within inside the environment. Perhaps there's a particular virtual machine that we don't know the owner of, IOPS are starting to run away, we actually throttle that on a per machine basis as well. And these policies can be applied to many VMs, so we can group virtual machines and apply a policy to it. We can have a default policy for the entire cluster, or indeed we can segregate it down and apply it to maybe a single virtual machine, or perhaps even just one VMDK of a virtual machine as well. And with inside vSAN Express storage architecture, we're not just about the vSAN itself, but we can export storage as well. And as this slide starts to build out, we can see on the left-hand side, we can export iSCSI storage. So we can export storage perhaps to a physical machine on the network that needs an element of shared storage within inside the environment. Where I see this often used today is in SQL clustering or Windows Server failover clusters. So we've got a cluster that needs shared disks, and we actually export that iSCSI storage to set up that capability. We can also export file services, so SMB and NFS shares exported out to Windows and Linux clients, and increasingly containerized workloads as well. Another real use case for, or another demand from containerized workloads is also S3 object storage. And so through a plugin to vSAN, we can actually export S3 compatible storage as well. See on the lower half of this diagram, we've got the concepts of data at rest encryption and data in transit encryption as well. Briefly touch on those. I think in my point of view, when we're enabling vSAN ESA and indeed OSA, they should be enabled by default, really. Very little overhead in them. And in actual fact, encryption is one of the capabilities we're going to be speaking about in one of these webinars later in the year. But at a very high level, we should enable it by default. And all we really need is an external key management server. We have some capabilities inside vSAN itself that we can actually enable those services as well. And of course, snapshots, right? So snapshots are included with vSAN by default. As we build out this diagram, what we're seeking to show is that the administrator can take snapshots through vCenter of the virtual machines within inside the environment. The graph on the right-hand side is seeking to show a couple of things here. So in vSAN OSA, original storage architecture, there is actually a penalty for having snapshots and keeping snapshots of those virtual machines. And what we tend to see is latency starts to increase of that VM with a greater number of snapshots we have, perhaps maybe around 12 or 14, and we start to see it tail off a touch. With vSAN ESA, that doesn't occur at all, a completely flat and linear approach in terms of latency. So very minimal, take as many snapshots as we need, and that really comes down from how we've rewritten that snapshot engine. In vSAN OSA, that was a redo log-based engine, and vSAN ESA takes advantage of the rewritten log-structured file system. So we're not really moving data around, we simply keep a map of the blocks, and we create pointers to those in order to create the snapshot. From the left-hand side here, we can see we want to have some good reporting, and certainly today we're going to have a demo, and we're able to see inside the interface some of the reporting capabilities that the snapshot engine has. Another thing with the vSAN ESA snapshots is also the advantage in stun times. So if we think about what needs to happen when we take a snapshot, we actually need to briefly pause I/O, create a point in time, and then resume that snapshot process. If we think about how our backup systems work, particularly those that are using the VADP API within inside vSphere. So those backup systems, they're speaking to maybe tens, dozens, hundreds, maybe even thousands of virtual machines within inside the environment. And there's a small pause for each of those every time that snapshot is requested. With vSAN ESA, that stun time has been reduced massively. So somewhere in the region to 80 to 100 times quicker. So we're thinking about how many virtual machines we have, those dozens, hundreds, thousands. We can start to shrink backup windows when we bring vSAN ESA into play. So everything I've spoken about here is all the standard capabilities within vSAN ESA today. So what's new? Well, with VCF 5.2 that had vSAN 8.3 as part of that release, we had something called vSAN data protection. And so this is a set of tools and workflows within vSphere that allows you to interact and work with the snapshots. We now need to revert, clone, and restore those. And so that's what we're going to be doing over the next few slides, is to really understand the kind of tasks that we can perform with this new vSAN data protection engine. So starting from the top on the left-hand side here. So yeah, we're able to revert snapshots to an existing point in time. So a classic use really. Clone virtual machine, so giving a copy of a point in time of a VM to an individual or group within the organization that might need a copy. We can also restore VMs that are no longer within vCenter, and we'll have a look inside the interface at how that looks like. You can see on the top across the diagram, there's also the notion of this padlock and immutable snapshots. So immutability means that we can lock those snapshots in place so they can't be deleted and removed from the environment. It's actually immutable snapshots that have a really important part to play in VMware Live Recovery. So VMware Live Recovery, a suite of add-on and data protection tools within the VMware Cloud Foundation suite that can enable protection of virtual machines. Specifically, VMware Live Cyber Recovery enables us to ship those snapshots off-site to enable recovery from perhaps encryption type events. And we'll discuss that in a touch more detail in a few slides' time. And yeah, we can also see we're starting to introduce the notion of protection groups as well. I'll explain what protection groups are as these logical units to actually group our virtual machines together. Overall, vSAN data protection should be really simple and easy to use. And that was a really focus of when it was developed. And our use of vSAN data protection falls in one of these four columns, really. Create. We're creating protection groups, that logical unit of virtual machines. We're enabling immutability mode. We don't want to use those snapshots to take a snapshot. We want to go back to a previous point in time, delete something, restore something, integrate with VMware Live Cyber Recovery. Some level of observability, reporting on our snapshot use within the vSphere interface. And there's definitely an element of system management, a level of automation and keeping a good health of the environment. Very easy to create snapshot policies that could run away and consume huge amounts of data. There's some guardrails that have been put in place. So yes, we will automatically expire snapshots that have exceeded our retention policy. We'll automatically expire snapshots that go beyond the 200 limits that we define for a virtual machine. And we'll also keep some health of that vSAN data store as well. So we'll pause snapshots we will pause snapshots if our vSAN data store goes beyond 70%. And that's really to ensure the health of it. Perhaps we've got, we're putting hosts into maintenance mode, for example. Perhaps we're changing a storage policy to move from RAID 6 to RAID 1. Perhaps we're doing an upgrade. We want to leave some overhead in that vSAN data store so we can move data around so we can recover from failures. And that's why that 70% is there, just to throttle it back and ensure we don't step into that and potentially put the health of the data store at risk. So now we're going to have a quick look over the interface. So what we have here, in a very simplistic point of view, but we'll have a demo and we'll look at this in more detail. So we've got on the left-hand side, we can see we've selected our cluster. We're reporting on the number of protection groups that are in play. We can see there's 121 virtual machines that are part of those protection groups. Perhaps we've got a policy in place that says, a business policy that says all of our virtual machines should have snapshots. We're reporting back that 17 of these aren't currently being protected. Perhaps you want to ask a VCF administrator to go in there, try and understand why these are falling outside rules, and put a policy in place to make sure they are protected. And yes, we're reporting on some capacity as well. And we also can see that from a particular protection group here, finance protection group, we can report on the number of snapshots, the fact that it's active, whether immutability mode is enabled. So I've mentioned protection groups a couple of times. So let's have a look at what those mean in a touch more detail now. So On the left-hand side here, we've got a protection group named HR VMs. Immutability mode is enabled. So what does that immutability mode mean? It means that an administrator can't go in, they can't delete those snapshots, they can't change the schedule, they can't age them out, and there's no real override. No super administrator can go in there. There's no root user that can dive in and try and change that. So some careful consideration needs to be put in as to how we enable immutability mode on a protection group. If we're snapshotting perhaps monthly and we're keeping those for a year, we could quite easily consume a large amount of space. So mindful use of immutability mode. However, they are extremely valuable to know that we've got confirmed points in time that we can always go back to. In this example, our membership is individual selection. So inside the interface, inside vSphere, we are choosing individual virtual machines that are going to be part of this protection group. In this example, we've got 2 SQL servers and we've got 6 HR virtual machines. And we've got a schedule in place. We're going to keep these, we're going to take a snapshot every day, and we're going to keep it for 1 week. We have another protection group here, so development virtual machines. So in this one, immutability mode is disabled. We've got individual selection of virtual machines again. So here we can see we've got 2 SQL VMs, and again, we've selected our 6 developer virtual machines. We have a schedule in place that looks very similar to the HR VMs. We're taking a snapshot every 2 days, and we're keeping these ones for 2 weeks. So now I introduce another concept. So dynamic membership of protection groups. So here we have database virtual machines. And so we're actually able to use a naming convention that will support a dynamic name assignment. So we can use asterisks and question marks within the name of that membership to actually pick up virtual machines. So in this example, the dynamic name is SQL-hyphen. And across those 2 HR and developer virtual machines, we're picking up all 4 SQL hosts. In this example, we've got 2 different schedules in place. In actual fact, we can have virtual machines can be a member of 3 different protection groups and quite an advanced number, but actually 10 different schedules for each of those virtual machines or each of those protection groups. So a large amount of flexibility, maybe adhering to different policies from different parts of the business. Application owners that want a very short retention period. Perhaps we've got a security team that wants to ensure that our virtual machines are kept for a longer period of time. So I mentioned this a couple of slides ago. So VMware Live Recovery. So VMware Live Recovery being a suite of software with VMware Live Cyber Recovery being a capability where we can use VMC on AWS, so one of the hyperscaler providers, or indeed Google and their GCP, or GCVE, so Google Cloud VMware Engine. We can actually ship snapshots off-site to one of those hyperscaler clouds. So how do we go about and do that? When we set up VMware Live Recovery in the cloud, we link it to our on-prem vCenter server. It is going to be aware that we have vSAN data protection enabled. It will be able to read snapshots that are already part of that vSAN data store and use those to replicate those to the cloud-based environment. And really what we're looking to do there is to create an off-prem secure environment to recover from things such as a cyber attack, perhaps where a virtual machine or a set of virtual machines have been encrypted by a malicious actor. The toolset gives us a way to find known good points within inside those virtual machines. So a set of workflows that will help us to identify a virtual machine and then move that into an isolated recovery environment. With inside that isolated recovery environment, we can actually do some analysis using tools such as Carbon Black to ensure that we can find a good point in time before that machine was encrypted, perhaps even before that machine had malware installed on it. And one of the really clever things that we can do between VMware Live Recovery and vSAN data protection is actually it will be aware of the known good point in time within inside the local data store. So it will look for a vSAN data protection snapshot that is before the point in time that we want to restore to. And so therefore, when we replicate back, we only have to replicate a subset of changes. So really efficient way of moving data back on site. And I'm sure this is a topic perhaps we can have a future webinar on as part of this series. So let's have a look at a couple of examples here. So in this one, this is just restoring to a previous point in time. So we're looking at a snapshot perhaps a machine has been, what might we have? An operating system upgrade has gone wrong and the virtual machine is no longer booting. Perhaps a virtual machine upgrade and services, sorry, perhaps an application upgrade has gone on inside the virtual machine and a set of services aren't starting. We've done an hour of troubleshooting and then decided, right, let's go to a previous point in time. We think it's going to be quicker to bring this VM back into production than spend any more time troubleshooting. You can see in the middle here, we've got an example. So we've got our SQL01 virtual machine. We're snapshotting every hour. So the process we go through, we find that virtual machine within inside the interface. We look for the snapshot that we want to use, and then we click revert. The live virtual machine will be shut down. The restore will happen, and then it's up to the administrator to then make the choice of when they choose to boot that restored virtual machine. And when I say restore, what we're doing here, because all the data is retained within inside vSAN, we're actually only changing the metadata. We're pointing that virtual machine to a different set of vSAN objects that construct that virtual machine disk, and then we're able to restore it. We're not pulling data down from the cloud from an external backup provider. We're not going to a backup to disk system and moving data across the network. We're simply changing the metadata of that virtual machine to have almost instant restores of these VMs. And so just a word on some of the limits there. So we can see that, yeah, so we've got a limit of 200 snapshots per virtual machine. So this isn't a backup system. So all of the data stays within inside vSAN, but it's a really useful tool for those VCF administrators. With inside vSAN data protection, so we can have our 200 snaps. If we are using only vCenter to snap, we still have a limit of 32 snapshots per virtual machine. So a real advantage from using the vSAN data protection interface and capabilities. Second use case, perhaps and probably one of the more powerful ones, is actually to be able to restore VMs that are no longer registered in vCenter, or as a shortcut to that, ones that have been deleted, maybe accidentally, maybe maliciously. So the process that we go through here, we've got an element within inside the interface missing from cluster, and perhaps we've gone through a process. What might we have? We've got a policy in place that says any virtual machine that's been powered off for 6 months gets deleted from the interface. It seems a reasonable policy to have. That we go through, we've deleted a virtual machine. A couple of days later, someone notices it, contacts the team, and says, I'd like my virtual machine back. And again, we don't have to go to an external backup system. We don't have to go to a cloud-based backup provider. We simply internally look at that VM and change the metadata and point the virtual machine to the objects that are on disk. So no need to create backup, no need to create tickets within inside an IT ticketing system, no need to bring in administrators of other systems, all within the control of the vSphere and VCF administrators. Another example, so this is pretty classic sort of copy data management. So what we're showing here is the ability to clone a set of virtual machines and present those out to a set of users that might need to do perhaps some testing. So a development team that are testing a new capability. Perhaps it's a team that are testing a patch that's being created, and we want to do that on a copy of those virtual machines before we put them into live. So a very lightweight linked clone that we can create from those snapshots. And there's a level of intelligence built into vSAN data protection as well. So vSAN data protection will know that these clones exist. And because of that naming convention we spoke about earlier, that dynamic naming convention, it will know not to add those to an existing policy. So lightweight linked clones for quick and easy use. Of course, if you want a full clone, we're always able to do that with inside our regular vSphere interface. And so, yeah, this is intended for, I guess, a short period of time, presenting out to a team and then rolling back that snapshot and rolling back that change. So as I've been talking through those capabilities, some of you out there might use vSphere replication today. Now, some of this stuff sounds familiar to what vSphere replication can do. So let's look at them side by side. So vSAN data protection, part of it is in the name, right? We are only able to snap and work with snaps that are part of a vSAN data store. So really it's about creating a large number of very quick point-in-time snapshots of virtual machines that sit within inside vSAN. And of course, can link to VMware Live Cyber Recovery. vSphere replication, slightly different. We are storage agnostic. We can use it with any array, including vSAN or any third-party array, and really we're able to move those snapshots to other systems or perhaps third-party hosting services. And really that's part of our 3-2-1 data protection strategy. So ensuring that we have a copy offsite on a different form of media as well. Both of these are included as part of your VCF subscription though. So each of these capabilities you can use today with VCF. And so just a bit of mindfulness about when to use each one and when is appropriate. But as we'll see in a few slides time, certainly I think these two capabilities are coming closer together, and the functionality that we have in vSphere replication today, we'll start to see move into vSAN data protection as well. So what I'm going to do now, if you just give me a couple of seconds, I'm going to move over to a demo environment, and we're just going to have a look at some of the interface with inside vSphere about how vSAN data protection works. Let me just switch over to a different environment. And yep, I can see we've got vCenter up and running. So how do we access vSAN data protection? So what we have here is a very basic vSphere environment. So we've got a cluster with a number of virtual machines running. And we'll find vSAN data protection within inside the configure section. And here we are. So what we're going to do, some of the things that we've just spoken about, see how this looks inside the interface. So what we've got an existing protection group in place here. What we're going to do is go ahead and create a new protection group. So from the top here, create new protection group. We're going to call this one customer services. We're going to use a dynamic naming pattern as part of this protection group. We can see on the left-hand side here, we've got a couple of CS core virtual machines. So what we're going to do is we're going to have CS star as our naming pattern. We click add, and then we'll see that those virtual machines have been picked up as part of this protection group automatically. We click next. And just a word in here. So if we go ahead and create a protection group, perhaps if we're going to snap if we snap every hour and keep this for 2 months, and we try and go ahead and create this, we'll be warned, right? We'll be warned that this exceeds the 200 snapshot limit of that virtual machine. So not a sensible policy to put in place for this virtual machine. So let's snap every day and keep it for 2 weeks. We will go ahead, create that policy, and we can see down the bottom in our tasks that will quickly go through and be updated. We then will have a new protection group that's been created. So we can see here we've got a brief alarm in place. So we won't actually have any snapshots until that schedule kicks in. So excuse my spelling mistake on customer services there. Let's go ahead and take a snapshot. A few seconds, we'll see again the processes run down in our task area. And what we're looking for here is the snapshot dates to be updated and that small alert to go away. And there we go, that's completed. So what we're going to do now is we're going to create a new virtual machine that adheres to the policy that agrees to the naming convention of part of this protection group, so it should automatically be picked up. So let's go ahead and create a new virtual machine. We're going to call this one CS Lab. Let's put it in our business apps folder. We're okay with this area. Yes, we're going to put it on our vSAN data store. Next, we'll change it to a Linux virtual machine, and we're going to have Photon OS. Go through and create that. Okay, in just a couple of seconds for that virtual machine to be created. So it appears in our inventory, and on the left-hand side, we can see those tasks have been completed. So at the moment, our customer services protection group has not yet included that extra virtual machine. So the next time that schedule kicks in, that's when it will pick it up. So if we go ahead and take a snapshot, wait for that to complete, look at the process again that's running in our task. And what we're looking for here is a new virtual machine to pick up the number of virtual machines to go from 2 to 3. And this is really showing to ensure that if you're using consistent naming conventions inside your environment, you can have people deploying virtual machines, and we know that they'll be picked up by that new protection group. And I think maybe I should have waited a little bit longer for that virtual machine to be created. I was taking another snapshot. Just wait for that to complete. And there we go now. So we can see that the number of virtual machines that are part of that protection group has now gone up to 3. Okay, so what we're going to look at now is restoring virtual machines. So in this example, we're going to go to that removed VM section. So if we just look at here, so virtual machines that have been deleted, migrated, or unregistered, but still have snapshots available. So here, we've got a machine called HR Core 3. Yep, that does not exist in our inventory at all. So we select it, and we simply restore VM. There's a single snapshot. There was a single snapshot from a single point in time. Let's again put that in our business apps folder. We're going to retain the existing naming convention and just next through and restore. And again, this is the point where, again, we're not going to an external backup system. So really quick to update the metadata and just have that machine updated and restore back to the inventory. And then we can see HR Core 3 has appeared. So the final thing we're going to look at is immutability. So if we look at these two protection groups that we've got in place here, we can see that we can edit, pause, and actually delete that protection group. So what we're going to do is we're going to create a protection group with immutability mode enabled. So let's call this one IT apps. We will tick immutability, and we're going to have a dynamic naming pattern again. For this one, it's simply IT and star, which should pick up our IT Core 1. Add that to naming pattern. Yep, indeed, it has been picked up. Go through, confirm the schedule. Give it a second, and we'll see a new protection group has now been created with inside vSAN data protection. And there we go, that's been created. But if we go and look at this one, we can see, so this is now locked. We can't edit, we can't pause, we can't delete. So finally, just going to have a look at the reporting. So what we're able to do here is really simply see the quantity of data that's been consumed by vSAN snapshots. So in this demo environment, really quite light, so 6.5 gig, but a huge amount of space still left on our actual data store. So giving those administrators real information about, do we have sensible snapshot policies in place, and can confirm that they're not consuming a large amount of data inside the data store. Right, I'm just going to pause this a second and we'll switch back to the presentation. Excellent. Okay, so what I was looking at there was actually from our hands-on labs. So that particular, I guess, example, demo lab is available for you to go ahead and look at. Really easy to find these labs. So labs.hol.vmware.com, or just search for VMware hands-on labs on Google. So there's that, plus lots of other VCF and vSAN VCF networking, ARIA Ops, so lots of hands-on labs capabilities that we've got in the area. So I would encourage you to go ahead and look at that. So one of the things that I said we were slightly forward-looking. So last year, August 2024, at VMware Explore, we announced VMware Cloud Foundation 9. And specifically within that was a set of capabilities for vSAN. And you can see here, there's a blog that's available on our website that goes into this in a little bit more detail. But some of these capabilities inside vSAN are actually going to improve what we do with vSAN data protection. So now what we're going to be able to have is vSAN to vSAN data protection, right? So we're going to be able to replicate from one vSAN environment to another. And we're actually going to have an RPO of up to, or down to 1 minute for that as well. So being able to use vSAN data protection as a really quality data, quality data protection and DR product that we can replicate between two sites. So what's that likely to mean? So if we think about that slide that I put up earlier, all of these capabilities that we spoke about here, we're able to have those at our second site. So having all of our VMs snapped, moved off to another location that we own within inside our environment and our network, to then be able to restore, clone, and go through those VMware live recovery procedures. So workflows to bring those VMs back up in another data center, but all within inside the vSAN ecosystem. So that's all I had today from, I guess, a demo point of view. But where can you go for a little bit more information? So there's 3 really interesting and really useful blogs and links that we have here. So if you want to find out a bit more about vSAN data protection, would encourage you to have a look at the vSAN FAQ section. So within there, really detailed and really quite useful questions that you might be asking yourself about how I could use this inside my environment. The Virtual Blocks blog as well. So some of my colleagues that are creating great articles there that will go into subjects around vSAN and vSAN data protection in more detail. So really a bit of a deep dive with some screenshots and examples and use cases about how to use these capabilities. And Cloud Foundation as well, right? So really there's a lot of articles being published in this VMware Cloud Foundation blog. I really encourage you to try and subscribe to that one if possible, but that's sort of the big picture platform point of view about our capabilities. If you've got any questions for me personally or about vSAN ESA, I'd encourage you to reach out to your Broadcom account team, or indeed my contact details are here. Please, drop me a message if you'd like to find out more. So this is the first in a new monthly series, and we'll be announcing dates and times and topics of the webinars that are coming soon. Behind the scenes, I'm sure we had people that are working on Q&A, and so if you've requested a follow-up as part of any of those, I'm sure we'll get in touch with you very shortly. But for this time, let me hand back to Carl to wrap up this session. Thank you.
Excellent. Thank you very much, Duncan. And really pleased the demo gods all worked for us there. It was all worked out very well. So again, just thank everybody for joining today. The next webinar will be on Friday, the 25th of April. We will communicate and update the Zoom invite with the topic we'll be covering within the next couple of weeks. There is a survey at the end of this webinar, so if you could please fill that in and have any suggestions for future sessions, we'll obviously take that into consideration and try and accommodate as many as we can. During next week, we will upload this recording to the registration page. So you'll be able to go back and rewatch it if there's anything which you particularly missed or if you wanted to share it. But just finally, a couple of things. I think most people will be familiar with the VMware user group. If you're not, I'd highly recommend going and having a look at vmug.com. There's several groups around the UK, and I know we've got some attendees in from a little bit further afield in the UK, but feel free to have a look in there. Get involved in the vMug community. Lots of great resources, lots to learn, and they run similar sessions to this. As Duncan called out, there's a whole set of environments and demos you can see as part of the hands-on lab catalog, so please go and take a look at those. And just finally, please go and spread the word. If you've enjoyed today and you would like to share with some colleagues, then share the link and and hopefully we'll be able to see you next time. So just final thing from me is thank you very much for taking the time, one, to register and for joining this session, and we look forward to seeing you next time. Thank you very much, everybody. Have a good weekend. Bye-bye.